Dear students, welcome to my classroom. We are solving the problems in the chapter mensuration, which are based on the volumes of combinations of solid objects. So we completed some problems in exercise 10.3, and in this class we are going to complete this exercise. So let us take the fifth one in the exercise. In the adjacent figure, the height of a solid cylinder is 10 centimeter and diameter is 7 centimeter. Two equal conical holes of radius 3 centimeter and height 4 centimeter are cut off as shown in the figure. Find the volume of remaining solid. Okay, this is the question. So in this figure, we can see that from the solid cylinder of height 10 centimeter and diameter 7 centimeter, two equal conical holes of radius 3 centimeter and height 4 centimeter are cut off. And we have to find the volume of remaining solid in the cylinder. Okay. So here the measurements are both cylinder and cones are given. The height of cylinder is 10 centimeter, and I am denoting this one as by capital H. And the diameter of the cylinder is given 7 centimeter, and from this radius of the cylinder is of the diameter, that is 3.5 centimeter. Now radius of each conical hole is given that 3 centimeters, which is denoted by small r, and the height of the conical hole is h is equal to 4 centimeter. So these are the measurements which are given in the problem. And now the volume of remaining solid after two conical holes cut off from cylinder is equal to volume of cylinder minus 2 into volume of conical hole. Because here the two conical holes are made on the both sides of this cylinder. So the volume of remaining solid is the volume of cylinder minus 2 into volume of conical hole. That is twice the volume of conical hole. So the volume of cylinder is pi r square h, and the volume of conical hole is pi small r square 1 by 3 pi small r square h. So pi capital R square h, because the radius of cylinder is denoted by capital R and the radius of cone is denoted by small r, and the height of the conical hole is small h, and the height of the cylinder is capital H. Okay. Now substitute the values of capital R, capital H, and small r, small h in this one. So 22 by 7 into 3.5 into 3.5 into 10, as well as 2 into 1 by 3 into 22 by 7 into small r is 3, so the 3 into small h is 4. So this product is equal to 2695 by 7 minus this product is equal to 528 by 7. So the result is 2167 by 7, which is equal to 309.57 approximately. So the volume of remaining solid after cutting off two conical holes in the cylinder is 309.57 centimeter cube, not centimeter square, it is a centimeter cube. Okay. So let us take the sixth one. Spherical marbles of diameter 1.4 centimeter are dropped into a cylindrical beaker of diameter 7 centimeter, which contains some water. find the number of marbles that should be dropped into the beaker so that water level raises by 5.6 centimeter. Okay. So there is a cylindrical beaker whose diameter is 7 centimeter and it had some water in the cylindrical beaker. Now some spherical marbles. Here I am showing only 3 for example, but there are exactly not 3 there. We don't know the number of marbles here. Okay. So some marbles are dropped into the beaker so that water level raises by 5.6 centimeter. So that is, now this is the previous level and this is the level of the water after dropping the marbles into the water. So now the shape of water raised is in the shape of cylinder, like this, isn't it? So the shape of water rise is also in the shape of cylinder whose diameter is equal to the diameter of the cylindrical beaker we have taken, and the height is increased by 5.6 centimeter. Level is increased by 5.6 centimeter. Now we have to find the number of marbles that we have dropped into the beaker so that the water level raises by 5.6 centimeter. Okay. So take this side. Now it is given that the diameter is 7 centimeter and the water level increases by 5.6 centimeter. So given the diameter of cylindrical beaker is D is equal to 7 centimeter. So the radius of cylindrical beaker is 3.5 centimeter. So I am denoting the radius of cylindrical beaker by capital R. And the rise of water level is in shape of cylinder whose radius is 3.5 centimeter and the height of the water rise is h is equal to 5.6 centimeter. And similarly, now the volume of the water rise is, which is in the shape of cylinder, is equal to pi r square h. Okay. So that is pi is 22/7, capital R is 3.5 and h is equal to 5.6. So which is equal to 215.6. So the volume of water rise is 215.6 cubic centimeter. Now the radius of the spherical ball is 0.7 centimeter because the diameter of spherical ball is given that 1.4 centimeter. So that its radius is 1.4 by 2. Spherical marble. Okay, 0.7 centimeter. Now the volume of the spherical ball is 4/3 pi r cube. So 4/3 into pi is 22/7, r is 0.7. So that the value is equal to 1.4373 cubic centimeters. Now let the number of marbles be n. Now the volume of water raised is equal to volume of the n marbles, because due to the dropping of these marbles, the water is raised to 5.6 centimeters. So the volume of water raised is equal to volume of the marbles that we had dropped into the water. So as I am taking the number of marbles here, the volume of water raised is equal to volume of these n marbles. Okay. So from this we can write the volume of water raised is 215.6, which we have got here, and the volume of marble is 1.4373. So from this, we get n is equal to 215.6 by 1.4373, which is equal to 150. So we have to drop 150 marbles to water level rises by 5.6 centimeter. Okay. So take another one. A pen stand is made of wood in the shape of cuboid with 3 conical depressions to hold the pens. The dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depression is 0.5 centimeter and the depth is 1.4 centimeter. Find the volume of wood in the entire stand. Okay, so here we have a wooden cube and 3 conical depressions are made to hold the pens. Okay, now this is the pen stand. And here the dimensions of the cube are 15 centimeter, 10 centimeter and 3.5 centimeter. And the dimensions of measurements of each conical depression is radius is 1.5 centimeter and depth is 1.4 centimeter. Radius is 0.5 centimeter and the depth is 1.4 centimeter. So after making these conical depressions, what is the volume of wood in this stand? That is the question. So from the top we can see like this. Okay. Now, given the length of the cuboid is 1.5 centimeter, 15 centimeter, and breadth is 10 centimeter, height is 3.5 centimeter. So I am taking these measurements as capital L, capital B, and capital H. Now, volume of the wooden cuboid is L into B into H, so that 525 cubic centimeters. Okay. Now, the radius of each conical depression is given by small r is equal to 0.5 centimeter and its depth, which we call height, is h is equal to 1.4 centimeter. Now, volume of each conical depression is equal to 1 by 3 pi r square h. That is 1 by 3 into 22 by 7 into 0.5 into 0.5 into 14, which is equal to 1.1 by 3 cubic centimeter. So this is the volume of each conical depression. Now the volume of wood in the stand after making these 3 conical depressions is equal to volume of wooden in cuboid minus thrice the volume of each conical shape, because we are making 3 conical holes here. So that the volume of wood in the stand is equal to 525 minus 3 into volume of each conical hole is 1.1 by 3. So that is 525 minus 1.1, which is equal to 523.9. So the volume of wood in the entire stand is 523.9 cubic centimeter. Okay. So this is the last question in this exercise. So students, now let's introduce about the conversion of solids from one shape to another. Okay. Students, in our daily life, we convert many objects from one shape to another for our needs. That is, we make jewelry from gold biscuits and we make home essentials and furniture from wooden logs and also steel vessels by melting steel bars, isn't it? But in this process, what kind of change in their volume occurs when an object is transformed into another form. Let us see. So here I have a beaker whose shape is in cylinder, and I had 2 liters of water in this beaker. Okay, and I had one more vessel which is in the shape of cuboid. Now I'm going to pour the water from the beaker into this cube vessel which is in the shape of cube. Okay, so before that, observe that what is the shape of the water in the beaker. We know that the water gets the shape in which the water is in, isn't it? So as the water is in the cylindrical beaker, it gets the shape of cylinder, and the volume of the shape of this cylindrical water is 2 liter. And as I'm pouring this water into this cubic vessel, now the water got the shape of cube. And what is the volume of the water in this cubic vessel? 2 liter, isn't it? Because I am taking 2 liter of water uh, in beaker, and I am pouring the water into the cubic vessel. So the volume of water in the cubic vessel is also 2 liter. So that is, the volume remains unchanged, isn't it? So the volume of water in cylinder is volume of water in cuboid. That is, if we change solids from one shape to another, the volumes of the objects will be remains unchanged. Okay. Similarly, if an iron bar is melted and made into cylindrical pipes, then volume of iron bar is equal to sum of volumes of all cylindrical pipes made from this iron bar. Similarly, if a cylinder is transformed into a cone, then volume of cylinder is equal to volume of cone. And also, if you melt some small spheres and make a large sphere, then volume of large sphere is equal to sum of volumes of all small spheres. Okay, students. So that is, we have to remember that if an object is changed from one shape to another shape, then its volume remains unchanged. Okay. So let us solve some problems regarding to this concept in exercise 10.4. So take the first one in this exercise. A metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. That is the question. So here there is a metallic sphere whose radius is 4.27 centimeters and is melted into recast into the shape of a cylinder of radius 6 centimeter. So now we have to find the height of the cylinder. Okay. So here the radius of the sphere is 7 centimeter and the radius of cylinder is 6 centimeter. So as we have to find the height of this cylinder, let us take h be the height of this cylinder. Okay. So now given the radius of sphere is capital R is equal to 4.2 centimeter and its volume is 4 by 3 pi r cube. As the sphere melted and shaped into the form of cylinder, the volume of cylinder is equal to volume of sphere. Okay. So in this process, so let us find the volume of the cylinder. So radius of cylinder is given that 6 centimeter, and let h be the height of the cylinder. So now the volume of cylinder is equal to pi r square h. So, but volume of sphere is equal to volume of cylinder, which we have already learned this thing. Volume of sphere is equal to volume of cylinder. That is, volume of sphere is, we have 4 by 3 pi capital R cube, and volume of cylinder is equal to pi small r square h. So now from this we can write h is equal to 4 pi capital R cube by 3 pi r square, because we have to find here small h, which is the height of cylinder. So that h is equal to 4 pi r cube by 3 pi small r square. So from this we can write h is equal to 4 capital R cube by 3 small r square. And now substitute the values of capital R and small r in this equation. So from this we get h is equal to 4 into capital R is 4.2 and small r is equal to 6. So by simplification, we get h is equal to 4 into 1.4 into 0.7 into 0.7. That is, I am dividing both 4.2 and 3 by 3, and 4.2 by 6 and 4.2 by the 6, which is in the denominator. So h is equal to 2.744. So the height of the cylinder is 2.744 centimeter. Okay. So in this problem, I am equalizing the volume of cylinder and volume of sphere. That's all. By that we can get height of the cylinder very easily. So take the second one. 3 metallic spheres of radii 6 cm, 8 cm and 10 cm respectively are melted together to form a single solid sphere. Find the radius of the resulting sphere. Okay, students. So let's solve this problem. So there are 3 metallic spheres of radius 6 cm, radius 8 cm and radius 10 cm. And these 3 spheres are melted together to form a single solid sphere like this. Now we have to find the radius of this large sphere. Okay. So by melting the small metallic spheres, this large sphere has made up. Okay. So now, as we learned earlier, the volume of sum of the volumes of these 3 small spheres is equal to volume of this large sphere. Okay. So here the radii of the small spheres are 6 cm, 8 cm and 10 cm. And let us take the radius of the large sphere as capital R. Now it's given that the radii of small spheres are, take these radii as R1, R2 and R3. So R1 is 6 cm, R2 is 8 cm and R3 is 10 cm. And let the radius of this large sphere, this big sphere, be capital R centimeter. Now the volume of this big sphere is equal to sum of the volumes of the small spheres that we have taken to make this large sphere. As the radius of big sphere is capital R, so volume of big sphere is 4 by 3 pi capital R cube. And similarly, the sum of the volumes of small spheres is 4 by 3 pi small r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube. So by taking 4 by 3 pi common, we get, and by cancel, we get capital R cube is equal to R1 cube plus R2 cube plus R3 cube. Now substitute the values of R1, R2 and R3 in this equation. So R1 is 6, R2 is 8, and R3 is 10. So from this we get R cube is equal to 1728. So R is the cube root of 1728. So by finding cube root of 728, we get capital R is equal to 12. So the radius of the resulting big sphere is 12 centimeter. Okay, students, that's all for today. And in the next class, we shall complete the problems in this exercise. Okay, until then, see you. Bye.